Good afternoon, Professor, and whoever else may be tuning in to this video. I'm Fire Control Technician, second class Michael Brown, and I'm going to present my project for ECT 295, and it's basically constructing and modifying a digital compass. Before I get into the actual presentation, I'd like to go ahead and tell you a little bit more about me. As I said before, I'm a fire control technician, and what that is, that's a rate on U.S. Navy submarines. What fire control technicians do, we track contacts, maintain these contacts a safe distance from on ship. We utilize, operate, maintain U.S. weapons systems and associated equipment, and when need be, we launch torpedoes and missiles. I'm currently serving as an instructor at Submarine Learning Facility, Norfolk, and there I teach submarine tactics and weapons employment. Before I started at Submarine Learning Facility, I was on the USS Newport News, also out of Norfolk, Virginia. I was there 5 years, did 2.5 deployments there. Been in the Navy total of almost 9 years now. Now that you know a little bit more about me, I would like to go into the actual presentation. Like I said before, the presentation was constructing a digital compass. Basically started with a blank circuit board, and from there we added all the extra components. When I say we, I mean we as in students, not like anybody's helping me or anything like that. Every student in this class had to do this. So I started with the compass module. That was the first thing I installed. So basically I installed it, soldered it to the board, and it did resistance checks using a digital multimeter. Once everything passed the resistance check, I went ahead and soldered everything else to the board. Once I got all the physical components done and out the way, it was time to do install the actual program. To do this, I used the PPP version 3 program that we got. I noticed that the compass program file that we got was not in the format that the chip accepts, so I had to use the Citrix flow code program to convert that over to hex file format. Once I successfully transferred the hex file to the chip, plugged it up, everything worked properly. We have a saying, it's kind of a joke on aboard submarines, if nothing's wrong, fix it till it is, and that's kind of what I did with this. So we'll until we modify it. So we made modifications, as you see right now. And it's displaying arrows, and let me spin it around a little so it always points one direction. So that's what the modification was. I like to explain the modification process and a 3-step process. The first process will be the design process. Basically, you have to take what you have and you have to figure out where you want to go with it. So basically, let's say for course north, you got to figure out which LEDs you want to light up to make the arrows point the direction you want them to go. And once you have this actual LEDs mapped out or written down or whatever you want to call it, you then figure out what pins that you need to modify, because some of the LEDs we use aren't already hardwired. So you have to we have to install jumpers, and I'll show you the jumpers from the back. Install jumpers to the board to actually make these connections. Once the design phase is done, then I work on the software phase. So after I figured out which LEDs I wanted to light up, I went ahead and changed the compass file program to make it display the arrows that I want to display for each direction. Once the actual software portion of it is out the way, I worked on the physical portion of it, which is actually installing the jumpers to the back. And again, I'll show you the back and let you get a closer look. It looks kind of tacky to me, but that's something I will discuss later on in the presentation. And once all the physical modifications were complete, I converted the new software program that I made. I call it Arrows. That's what it's displaying. And I converted that from the original file format to hex, because again, it's the file format that the chip takes. Then I used the PPP version 3 program again to download this to the actual chip. And once downloaded, it worked properly. Again, as you can tell. So, the things that I actually had trouble with, things that I actually had to troubleshoot, the few things. I would say the biggest thing would be the operation of the PPP version 3 program. That's something I had no experience with. I had a little trouble soldering, but that was easily overcome. But by far the hardest thing was the PPP program. Originally, when I first downloaded it, I got error codes and all kinds of stuff saying that I need a 64-bit version of it. What I ended up doing is I had a disk that came with the multi-grammar board that I had, and I installed a version of it from that. The actual 64-bit notification did go away, but the program still didn't work properly. So I decided to uninstall that program again and actually reinstall the old one. And the 64-bit error came back again, reoccurred, and I decided to try to work past it. I just employed a few of the troubleshooting techniques that I learned on submarines, and no, not the hit it with a hammer version, but the actual check the power, check the connection type thing, and I actually found a solution. I noticed that when I took the chip from the multi-programmer board, that it was seated a lot snugger than what my chip was sitting at, and I also noticed that it had a power supply slot, but the multi-programmer didn't actually come with actual power supply. So I used the power supply from my I/O board and plugged it in, seated the chip firmly, and it worked. The improvements that I would actually make to this compass, again, looking at it, it serves a function, but it doesn't look really user friendly. I mean, you have the battery hanging from a wire. If you let it go of the battery, it's going to stress this wire, it's going to break. You have the jumpers on the back, and as soon as you sit that down, it's being constantly stressing those connections every time you move the compass around. So the first thing, or the major thing I would do is to fabricate a case for it, so these wires would be protected, and it would keep the battery in place, and it would protect all the wires, and everything would be fine. In conclusion, I really enjoyed this project. It's one of the few projects that I can actually see myself using this thing in everyday life, and I feel that I will retain more of this because it's so grounded. I mean, it's not like some of the other projects that I had to do where as soon as I'm done with the class, I'm never going to even look at that again or ever use those skills again. But this one, I would definitely take a lot of information from this. This project actually makes the student demonstrate that he or she is well-rounded, and that you can do things such as reading schematic and soldering and actually reprogramming stuff. Again, I really enjoyed this project, and I hope you enjoyed this presentation. Thank you.